Okay, here we are again for some more lovely maths. Last time you were finding the gradient, the slope, the steepness or the m when given a graph. This time I have changed it. We're going to give you 2 points. Now if you did well last time, what you're going to think is, this is so easy. All I have to do is draw a graph and do what we did last time. Well, you could, but I'm going to show you an algebraic way to do this. And you might like it because it's faster. So we're going to use the ideas you used last time and then we're going to apply it to form a formula. So here we go. If I had given you 2 points, you could have plotted them and joined up the line. And if we used the method last time, you would have used the numbers for the coordinates here and here, and you would have worked out the change in the x direction and the change in the y direction. Then you would have written this formula, change in y divided by change in x, placed the y change number here, the x change number here, and got yourself an answer. But if you look here, I have not written numbers for the coordinates this time. I've written x1, y1, and a pair of coordinates here called x2, y2. Please note these numbers are in the bottom right hand corner. They're called suffix numbers. They're a bit like if you play football and you have a number on your shirt and on your shorts. They would match. Or if you were in a ballroom dancing competition dancing with your partner, you would both wear the same number. So x1 is dancing with y1 and x2 partners y2. Do make sure though when you write these, people do this wrong all the time, they write it like this. Don't do that. Also, don't do this. They're both wrong. This one just looks like you don't know how to write 2x properly. This one looks like you're doing x times x. Neither of these are correct. We're not doing either of them. So, last time what you used to do is write the y number over here, which I'll do, y2, and its x number here is x2. Over here the x number is x1, and this time it's going to be the letter y1. So last time when you worked out this distance, you took this number and subtracted this number. So let's just do that again, but with the letters. Last time when we had to calculate this, you took this value and subtracted this value. So let's just do the same thing again. So now, where we've got the change in y, I've got y2 minus y1. So instead of a number, I can replace change in y with this. This time, the change in x isn't a number, it's this algebraic expression. So let's pop that in. Now we've got a new formula. M equals y2 minus y1 divided by x2 minus x1. That's great. Now I can use a formula to solve these types of problems instead of having to write a graph. So first of all, you need to pause the video and make sure you copy down these notes. And then the next thing we'll do is a worked example. Okay, did you copy these notes down carefully? Right then, you're asking yourself, where's the worked example? Well, just wish really hard for a worked example to appear and let's see what happens. Now, you wished hard enough and now we have the example. So this time, as you can see, we're not going to draw a graph. We're going to use this new equation. Now, if I write an equation, you should always list your variables. What does that mean? Well, let me show you. So what we need to decide now is which numbers go with which of the letters. Now remember, x1 pairs up with y1 and x2 pairs up with y2, like ballroom dancers. So if I decide that this number here is x1, can you think who must be y1? Pause the video. Have you got an answer? Did you say 2? Okay. Now decide which numbers go here and why. Have you got an answer? Let's see if you're right. x2 is going to be 5 and y2 is minus 10. Now if you had decided that you wanted to call this one x1, then this one would have had to be called y1. Then this one would have been called x2, and this number here too would have been called y2, and that's okay too. Now when you have a list of variables with values and a formula, the next thing to do is bring them together. This is where I always say to use Peter and Paul to make sure you put the values in the right place. Let me show you what I mean. First of all, y2. A minus sign is a minus sign. y1 is 2. The bar line. x2 is 5. The minus sign is a minus sign. The x1 is 1. Using Peter and Paul will stop you from making copy errors. Thank you, Peter and Paul. Now all you have to do when you have good setting out is just read what has been written. So decide what you think you have to do next. Pause the video. Okay, you think you've got the right idea and you have the answer to what we have to do next? Let's see. M equals. You should have heard a voice telling you to do minus 10 minus 2. And of course you get negative 12. Then you should have also heard another voice going 5 minus 1, which of course makes 4. From here, you should know to simplify. Just as we did when we had the values, when we were using a graph. Now what's different about this compared to last time? Well, when we had gradients that were going in this direction, they're called negative. And when we were using the other method, we had to remember to put a minus sign in. But what has happened as if by magic? Yes, the minus sign appeared as if by magic. So what's great about this is you don't have to worry whether the line is going this way, positive, or this way, negative. The formula will do it for you automatically, as if by magic. Okay, the next thing to do is copy this in your notebook and then you can start the exercises.